long history of mankind, there has never been a war which has demanded such complex tactics and so many sophisticated weapons as the war in Vietnam. An entirely new concept of warfare, known as heliborne, or air mobile operations, has been developed by the United States Army and has been successfully employed to meet the problems posed by Southeast Asia's hostile wilderness and the enemy who hides there. In the fluid situation where actions are fought from one end of South Vietnam to the other, the air mobile concept has given birth to the Army Air Mobility Team. The first thing that the Army had to overcome in Vietnam was the terrain itself. Approximately 80% of the country is undeveloped wilderness, or in the southern part of the Republic, endless marshes, bogs, and waterways of the Mekong Delta. All of the land features which are unfavorable to a modern, highly mechanized fighting force are used by the Viet Cong as a weapon against the American military effort there. Seeking out the elusive, hidden enemy, U.S. troops are daily confronted by nightmarish natural obstacles. Even at close range, the Viet Cong remain unseen. The full power of our Army cannot be brought to bear upon the enemy through ground operations alone. As the American fighting men inch their way into the Asian wilderness, where the enemy has prepared underground fortresses and has entrenched himself for decades, the attack spirit of our troops is frustrated, and progress is limited. A speedier, more effective method of getting at the Viet Cong and North Vietnamese Army forces had to be found. Traditionally, the need for ground movement by the Army is vital. Troops are still deployed on a massive scale on wheels and treads in Vietnam, and the final victory must be won on the ground. In order to move quickly over difficult ground and to put the firepower where it's needed, the Army developed the air mobile concept. This concept requires that Army aircraft be employed by and assigned to the fighting division. These aircraft and the men that fly them are immediately responsive and solely committed to support of the ground commander. For overland transport, the Army still needs its workhorse vehicles, ambulances, and various types of armored war machines. These are the tools of the ground force elements of the air mobility team. In the air mobile divisions, many of these ground vehicles are replaced by helicopters, which carry the men and equipment of the team. How the air mobility team system works is demonstrated in a battalion-sized operation to search out and clear away known enemy forces. Advanced reconnaissance is the first step for any planned attack. In air mobility operations, this advanced scouting is usually done from the air. Light, fixed-wing aircraft look for areas near suspected enemy positions, which will provide a suitable landing zone for the waves of assault troops, which will soon be coming in. To determine enemy strength in the area, helicopters are sent in for a closer examination of the ground. From intelligence reports and the information gathered by air reconnaissance operations, pilots and air mobile officers are briefed on the mission which lies ahead. From day to day, heliborne missions vary so much that these briefings must be extremely accurate. Ground commanders are also given the latest information on the operation. The operation begins when the infantry soldiers load aboard the assault Hueys to fly to the strike objective. The air mobile team concept is designed with the idea that the airborne soldier must ultimately fight on foot. Every effort is made to keep small units together on the same aircraft. A combat company's mortars and machine guns are divided among several aircraft, however, so that the loss of one or two helicopters would not knock out all the company's heavy weapons. Troops are seated in each attack helicopter so that the first man off will be an automatic weapons man. If necessary, he will provide a heavy volume of fire to cover the offloading of the rest of his squad. The aerial deployment of assault troops may call for some modification of normal leadership tactics. On the ground, the company commander will be up forward. However, in the air like this, the command and control ship may well be the last one in formation. This gives the troop commander a clear view of his entire unit and allows him to break out of formation without disrupting it. In air mobile operations, such as the one now underway, the hilltops overlooking an enemy-held valley are pounded by Army artillery units to make way for the incoming waves of helicopters. Artillery fire is carefully coordinated with attacks directly upon enemy positions by tactical aircraft of the U.S. Air Force. The jets rain bombs into the valley to neutralize the enemy there. When the fighter-bomber attack is masked by the advance of the ground troops, the close support is continued by helicopter gunships. Helicopter gunships lay down suppressive fire with 2.75 rockets and machine guns when required. Using the position-marking rockets of the helicopter as a guide, the Air Force jets dart in with their heavy ordnance. The landings of the assault helicopters are the most critical phase of the operation. Despite the heavy preparatory fires, enemy small arms, automatic weapons, and mortar fire may be severe. The attacking airborne soldiers must be ready to engage the enemy immediately with every type of weapon. They also must deploy swiftly to push back or eliminate enemy forces which may be blocking expansion of the landing zone. The air mobility team system provides another great advantage for the assault troops. In addition to flexible, rapid transport to meet any maneuver of the enemy, the U.S. infantrymen can be landed on key terrain, such as this high ground overlooking the valley. Known as vertical envelopment, this enables him to come in behind the enemy, whose prepared defenses are usually oriented to cover the ground below. As the initial landings are completed without resistance from the enemy, the men spread out quickly to secure the various landing zones. Another advantage in landing atop high ground is that the assault forces are unable to attack downhill. This decreases fatigue and speeds up ground movement. The enemy is given little time in which to adjust his defenses to the attack. In an effort to land behind the enemy, some of the troops are required to land on terrain where natural obstacles make it far from an ideal landing zone. But the men of the air mobile team are extremely resourceful and manage to complete their landings despite the hazards. Here, for instance, some of the troops must descend into the solid mass of tall jungle in order to take up a strategic blocking position. The descent is made with the aid of a trooper ladder. An air-mobile landing, which has been slowed down by difficult terrain, is vulnerable to attack by the enemy. In this situation, it is vital to have suppressive fires placed on the perimeter of the landing zone by the fire support elements of the air-mobile team. The artillery forward observer plays a critical role, calling in and directing artillery fire. Another triumph of the air-mobile team is its truly remarkable ability to shuttle artillery through the air. In Vietnam today, most aerial delivery of these field pieces is being accomplished by huge Chinook helicopter sling delivery. New lightweight howitzers have been developed especially for this role. From these forward battery positions, the artillery can not only support the troops moving up in the field, but can cover the landings of other battalion-sized units at nearby satellite landing zones. Further support for the foot soldier comes from the Air Force. The Air Force counterpart of the Army Forward Observer is the FAC, the Forward Air Controller. Riding in Air Force spotter planes, the FAC can call in devastating jet airstrikes on enemy positions. The Air Force provides close air support until it can no longer attack the target without endangering our own troops. Spectacular though the air-mobile team's assaults are, these brilliant aerial deployments would grind to a halt on the ground if the troops were not constantly supplied and resupplied with the many articles of war needed to fight the battles. Things like jeeps and water trailers and ammunition. Prompt delivery of mail, communications equipment, small arms ammunition, and food is a vital part of every operation. Pure fresh water supplies are as important as food, due to the fact that natural water sources in Vietnam are carriers of disease. One of the most outstanding aerial delivery feats, however, is the constant shuttling in of tons of heavy shells, which are consumed so rapidly by the forward artillery units. Aerial resupply means not only materiel, but manpower as well. The Army Air Mobile Team's ability to rush reinforcements by helicopter and move troop units to keep up with rapidly changing situations on the ground has led to some of the Viet Cong's most crushing defeats. The enemy could not anticipate the reaction timing of this swift air mobility. Keeping the swarms of helicopters airborne so long and so often is made possible only because the team gives these aircraft expert maintenance on the ground. Checkups and inspection procedures are exacting and carried out according to a rigid schedule. After every combat mission, an inspection is made for possible damage. Another contributing factor to the capability of these helicopters to return so swiftly to action is the multiple fueling techniques devised by the team's ingenious support personnel. Inflatable rubber fuel tanks, flown well forward of the main airbase, cut refueling time to the bare minimum. No supporting role is more brilliantly and widely carried out in air mobile operations than the role of the combat engineers. They, too, take to the air along with their equipment and supplies to perform their key function of clearing the way for the fighting infantrymen. They not only give the troops ground mobility by clearing and building roads, but they erect bridges to span rivers and gullies in the underdeveloped provinces of South Vietnam. They further the team's aerial mobility by laying down metal runways and aprons for the big airlift and resupply operations. Another important mission of the engineers is the systematic, expert demolition of enemy underground fortifications, tunnels, and other obstacles. Once discovered by our ground troops, such enemy bunkers are never allowed to stand intact. Probably no feat of the air mobile team is as spectacular or heartwarming to the fighting man as evacuation of the wounded by medical helicopter. The swift removal of wounded soldiers from remote battlefields and aerial delivery to modern hospital facilities has cut combat fatalities to an all-time low. It is no wonder that this life-saving capability of the Army Air Mobile Team is one of the major factors in sustaining the morale and fighting spirit of the soldier. The special nature of the Vietnam War has called for application of the air mobile concept in ways never expected by the men who developed the system. Sometimes it may be the evacuation of the native populations of a remote Vietnamese village, which is suspected to be a base of operations for the Viet Cong. More cheerfully, it may be a means to implement the program in which villages and hamlets are visited by the Army's Civil Assistance Team, bringing aid to the needy villagers through gifts of food, medical care, and clothing. In some of the more remote hamlets, the people have never known modern medical care, and this phase of the program is especially welcome. Where food is concerned, the hearty, wholesome meals fed to the villagers are a prime ingredient in the program. The hearts of many are won over through the gift of food. There is even entertainment to delight the villagers. These activities are just another example of the Air Mobile Team's remarkable versatility and scope of operation. The self-sufficiency of the Air Mobile Team is one of its most valuable assets. An example is the helicopter recovery of damaged aircraft. Since the wrecked aircraft is most often the victim of enemy action in the forward areas, these recovery operations are frequently carried out while the rescue ship itself is under fire. However, the men of the recovery teams are so skilled, so quick, and so daring that most aircraft shot down or forced down by accident are recovered, repaired, and are returned to combat duty again. Even the largest of our helicopters can be retrieved from wilderness crashes and whisked back to the capable hands of expert aircraft repairmen. The Air Mobile Team concept has its most classic application in actual combat. In a typical operation, troops of the 1st Cavalry Division Air Mobile, supported by mechanized units, discover a regimental-sized force of North Vietnamese Army regulars in the foothills near Bong Son. The enemy is deeply entrenched in an area adjoining two villages. Progress is halted because of enemy mortar and automatic weapons fire. A combined armed fire mission is imperative if the ground forces are to succeed in dislodging the enemy from his system of hidden underground fortifications. Supporting fires must be called in. First to respond are the Huey Cobras, gunships, and aerial rocket artillery ships. Simultaneously, the supporting artillery units fire concentrations on the entire enemy position. Finally, our ground forces begin moving up. They are greeted by well-disciplined fire from North Vietnamese Army troops who have escaped the aerial attack by burrowing deep into their underground bunkers and tunnels. So it is all over. The Army Air Mobile team has prevailed. The enemy has been defeated in this confrontation with the Americans at Bang San. One thing is clear. The battle-tested teams of infantry and armor, infantry and artillery, and the many other combined arms teams still play their historic roles in battle. But their missions are carried out faster and more effectively as part of the Army Air Mobility Team.
Okay, move out.
Much has been written on the subject of military history. Army planners of today have learned many important principles of combat operations from military engagements of the past. Regardless of their historical background, all armies shared one common problem: how to get the soldier what he needed to win his battle, when he needed it. The military term for this support is logistics. And from earliest times, this problem was of grave concern to military leaders. Alexander the Great worried about supplying his expeditionary forces, which stretched from Greece across Asia Minor to northern India. Alexander's military campaigns were successful mainly because he was able to hold the Mediterranean coasts of Palestine and Syria. He used these coastal areas as supply bases, or depots as we call them today. From these bases, he was able to replenish his armies with the supplies and assault equipment necessary to win victory. 100 years later, in a war against the Romans, Hannibal crossed the Alps from Spain and faced a similar problem of maintaining an army stretched far beyond its borders. Unable to obtain mastery of the seas around southern Italy, Hannibal did not have the advantage of coastal supply bases. Supply lines by land over the mountains proved inadequate, and eventually Hannibal's military efforts in Rome failed. Napoleon's armies marched to disaster when they invaded Russia in 1812, without adequate provision for maintaining the troops through the rigors of the Russian winter. Military history is full of similar examples which demonstrate the importance of logistical support for the fighting man, and the critical role it plays in the outcome of battle. In our own time, U.S. military operations during World War II included a massive logistical support effort in both Europe and the Pacific. With large armies fighting on all types of terrain, halfway across the world from each other, logistical planning in World War II became a task of immense scale and complexity. And again, the lesson of military history was proved. The will to win victory must be matched with the means for achieving that victory. Today, on The Big Picture, we will see an account of another massive logistical effort, providing the combat material and services necessary to support United States Army military operations in defense of free South Vietnam. major part of the supplies and equipment sent to Vietnam begin their journey at ports on the west coast of the United States. Delivered to the docks for shipment overseas are all supplies, weapons, and facilities necessary to equip, transport, and maintain our Army on its Vietnam mission. Many important supply items are taken aboard in specially developed containers to facilitate loading and unloading. Everything from food, small arms, ammunition, and medical supplies to helicopters and heavy weapons must be available in good condition for delivery to our fighting men. Military supplies and equipment are brought into Vietnam through various ports and landing areas. Major ports are Saigon, Newport, Quy Nhon, Da Nang, and Cam Ranh Bay. Materiel is moved inland from the ports and coastal areas to regions closer to the combat area where support depots are established. With the rapid buildup of U.S. forces in Vietnam in 1965, crowded port facilities at Saigon had resulted in a backlog of as many as 40 ships at a time, waiting in the harbor for a place to unload. Today, an extensive port modernization program has greatly increased the efficiency of cargo handling. Cooperation between the South Vietnamese authorities and the U.S. Army transportation personnel has cleared the traffic jam from the harbor. Methods for unloading cargo have been improved through careful study of terminal management techniques. On Saigon's docks, cargo is shifted quickly and easily by forklifts. Because commercial and aid cargo also arrives at Saigon, the port's facilities are always heavily burdened. Over 200,000 tons of military cargo may be unloaded here in an average month, and an equal amount of commercial cargo. Even with improved port facilities, the movement of cargo through Saigon is often hampered by traffic in the city's crowded streets. To help relieve the logistical burden on Saigon, the Newport Transportation Terminal was built 3.5 miles upstream from the capital. 4 piers can accommodate heavy cargo vessels. Equipment and supplies arrive here from various U.S. Army depots. But it is at Cam Ranh Bay on the South China Sea where the full extent of the United States Army's logistical buildup in Vietnam can be most dramatically illustrated. In 1965, these shores were a sandy wasteland. Army engineers were assigned the job of turning this area into a major service and supply base. Everything had to be built, everything that would be needed for total troop and combat support. A type of docking area was installed known as the De Long Pier. The device was a large, barge-like platform supported on steel pilings driven into the bottom of the bay. De Long piers are in wide use at many South Vietnam coastal supply points. By late 1966, a De Long pier for the handling of ammunition was completed at Cam Ranh Bay. Located for safety at the end of a long causeway, the pier is able to handle 1,000 tons of ammunition daily. Ammunition arriving from the United States is moved out as quickly as possible by land, sea, and air to the various combat sectors. Petroleum products for U.S. Army aircraft and vehicles are handled at specially built facilities. This jetty at Cam Ranh Bay can accommodate large tankers, from which petroleum is pumped at the rate of over 400,000 gallons an hour. A few miles inland, a tank farm stores the petroleum for use as it is needed. A variety of general support maintenance units services military equipment. The watchword here is inspect and repair only as needed. The aim, get the equipment back to its combat unit with the least possible delay. What was formerly a sleepy fishing village has become a dynamic modern port, capable of offloading, processing, and transshipping immense quantities of urgently needed military supplies and equipment. Nearly 25% of all the military logistical supplies coming into the country enters here. The remarkable development of supply and service capabilities at Cam Ranh Bay is typical of the U.S. Army logistical buildup throughout South Vietnam. Often, supplies must be concentrated in areas where port facilities are either inadequate or entirely unavailable. In these cases, ships anchor off coast and cargo is unloaded over the side onto lighters. Known as logistical over-the-shore operations, this method of bringing in materiel adds considerable flexibility to the Army's supply activity. All major logistical centers are strategically located for the most effective distribution of combat and combat support items. The extent of the logistical problem in Vietnam can be readily understood by a look at the average military tonnage per month of key supplies brought into all of South Vietnam in 1967. 45,000 tons of ammunition, 60 million gallons of petroleum, 10 million food rations. By far the greater amount of it coming in by ship. This, of course, is in addition to the thousands of tons of general military cargo, including heavy weapons, vehicles, and equipment, which must be stored, maintained, distributed, and serviced. How does the Army keep track of this vast input of costly combat materiel? Once at the coastal areas, how do the supplies actually get to the troops in the rice paddies and central highlands of South Vietnam? And what about the many essential logistical support services so necessary to the Army's mission? The answers to all of these questions lie in careful planning and organization of our logistical facilities in the Pacific. Until 1967, these facilities at Okinawa, headquarters of the 2nd Logistical Command, were the marshaling point for Vietnam-bound military supplies and equipment. But pressing and increased logistical needs required shipment of the vital combat material directly to South Vietnam for more immediate deployment. Much of the heavy-duty maintenance on military equipment is still accomplished on Okinawa. An automatic data processing facility handles requisitions from combat units in Vietnam for supplies from the continental United States. Linked directly to the Okinawa Command is the 1st Logistical Command at Long Binh, South Vietnam. Here, an inventory control center, working in conjunction with the Okinawa base, keeps records of existing supply stocks in Vietnam and determines future needs. The 1st Logistical Command is responsible for the distribution of combat supplies and equipment coming into the country for United States and other free world troops. This is the largest single Army troop command, with over 60,000 personnel trained in supply and maintenance operations and servicing American and Allied soldiers throughout Vietnam. From ammunition to rations, from gasoline to bridges, from medical supplies to housing, the 1st Logistical Command supports the soldier in the field with everything he needs to sustain him in his combat mission. Before setting out in supply convoys, drivers of Army trucks are briefed on possible hazards up ahead. These men carry weapons and know how to use them should the Viet Cong attack the convoy. Most supply items move by truck from depots to forward support areas as close as possible to the combat zone. Road conditions in Vietnam are not always equal to the task. Many combat areas cannot be reached at all by vehicular traffic. Where road access is not available, helicopters touch down on landing pads and bring in the precious cargo. The Army's heavy-duty helicopter, the CH-47, known as the Chinook, can carry everything from heavy construction equipment to an entire troop unit directly to the battle zone. For longer hauls, cargo aircraft make the run from depot to forward support landing fields when they are available. Each forward support area keeps a stockpile of all classes of supplies geared for the particular type of unit it supports. Supplies are kept at levels necessary to support the speed and intensity of the unit mission. At all times, contact is maintained with 1st Logistical Command Headquarters to make certain that additional materiel will be on hand as needed. From these stockpiles close to the battle area, combat units will draw what they need to continue the fight against the enemy. While much of our troops' strength can be supplied by vehicles and aircraft, in the southern Delta region, made up largely of wetlands, logistical support must often be accomplished by water routes. Assault craft carry the men to battle, and the combat material they need must be readily available. Assault boats, barges, and other craft are used on navigable waterways to bring supplies and equipment to the men. Everything the soldier needs to do his job goes by water. Floating firing platforms are one of many logistical support facilities that must be provided for the riverine force. Transportation boat companies supporting combat operations in this area have a wide capability for maneuver. Combat support rivercraft are moved wherever they will best serve the unit mission. Maintenance barges can repair Army aircraft and military equipment on the spot to avoid taking the vitally needed items out of battle. Support for Army combat activities is performed by another important water-based facility, the Army Aircraft Maintenance Ship Corpus Christi Bay, anchored off the coast of South Vietnam. The vessel carries a team expertly trained for every major aircraft maintenance specialty on rotary or fixed-wing Army aircraft. In battle, time is always critical. Aboard the floating maintenance ship, valuable hours or even days are saved in repairing equipment that might otherwise have to be sent to U.S. bases in the Pacific or back to the United States for maintenance. The diversified Army forces in Vietnam require this same capability for skillful repair in dozens of other Army specialties. Equipment such as armored vehicles pose a particular maintenance problem. tanks, armored personnel carriers, and other combat vehicles may be disabled not only as a result of enemy action, but from the rigors of heat, humidity, and difficult terrain. Literally hundreds of items of essential combat equipment, from the smallest to the largest, must be serviced without delay and maintained or quickly restored to combat readiness condition. Maintenance is one of the foundations of logistical support. The Army's maintenance organization provides this support from field repair close to the combat zone to the more complete maintenance capabilities at the larger logistical bases. Thorough command and control along the entire chain of logistical support assures that carefully planned combat operations can go forward uninterrupted and with greater chance of success. Though surface transportation accounts for the major supply movement in Vietnam, airlift is vitally important in getting essential repair parts to their destination. At Tan Son Nhut Air Base outside Saigon, the Red Ball Air Express operation expedites the flow of repair parts for military equipment of every kind. Like all combat materiel, Red Ball inventories are kept at levels sufficient to meet critical needs. Red Ball shipments are given high transportation priority so that badly needed repair parts may be transshipped to combat units without delay. Though supply and maintenance of troops and equipment form a cornerstone of the U.S. Army logistical effort, many other support services are indispensable to combat operations. Army engineers paved the way for the creation of logistical facilities. Engineers have developed new and more effective methods of clearing jungle regions for helicopter touchdown zones or landing strips for Army aircraft. Of great importance is clearing jungle growth to reduce the possibility of ambush in areas where our troops are conducting combat operations. Another method of clearing areas where the enemy may hide is by defoliation, or chemical spray, which inhibits the growth of foliage. Airstrips too soft for the weight of heavy aircraft may have to be prepared with specially designed synthetic surfaces. Facilities for preparing construction materials such as concrete or asphalt are operated by Army engineers. Guaranteeing adequate supplies of safe drinking water for the soldiers is an important engineer responsibility. At water purification plants, continuous tests are performed on water resources. With combat troops in remote, hard-to-get-to areas, often under enemy fire, feeding our troops in Vietnam is a difficult logistical problem. Food is brought into bivouac areas by truck wherever possible. When surface transportation can't get through, food and water are airlifted in. If there's no place to land, the chow is airdropped to the combat unit. While engaged in active fighting, soldiers receive combat rations consisting of complete appetizing meals which may be eaten hot or cold. New methods of processing and preserving fresh foods for the troops in the field are constantly being developed. Care for the individual soldier in war or peace has always been a major concern of the United States Army. In Vietnam, medical evacuation of the wounded may call for special logistical support in equipment and operational methods. This rescue hoist mechanism can lift a wounded soldier out of a jungle region with the aid of a specially rigged seat. Coordination between rescue units and Army hospitals throughout Vietnam provides quickest possible transportation of the wounded from the scene of battle to the nearest medical facility. Logistical support for the fighting man includes providing for his relaxation as well as his duty assignments. Entertainment is often arranged at base camps and hospitals. Provision must be made for transportation and housing for the casts of traveling shows. This company of entertainers stars Martha Raye in a special performance at the 2nd U.S. Army Surgical Hospital in Vietnam. To support the fighting man with latest technological advances in combat materiel is a continuing objective of Army logistics. This air-mobile firing platform is being placed by helicopter in a flooded rice field. A 105-millimeter howitzer is brought in and positioned on the platform, providing a unique artillery emplacement. An innovation in locating enemy troops is the airborne personnel detector. Operated by men of a chemical detachment, the device is secured to an Army aircraft. Sensory apparatus on the detector will signal the presence of the hostile troops in suspected areas. Many new combat support devices and concepts are tested and proved under actual combat conditions. Inevitably, success on the battlefield depends on total logistical support in every phase of combat operations. Whatever the supplies or services required, wherever they must be available, the need is always urgent. The time is always now. Army behind the Army. The personnel who back up our fighting men with supply, maintenance, and service are indispensable to our military effort. They are, in fact, our pipeline to victory. The famous 19th century Prussian military strategist Karl von Clausewitz summed up the purpose of Army logistics vividly in his famous series of essays on war: to bring every available man, horse, and gun to the battlefield in the shortest possible time and with the utmost momentum. In terms of our modern, more sophisticated military ways and means, that is what we are doing in Vietnam today. That we are providing total support for the fighting man is proven by this significant fact. Not a single United States Army combat operation in Vietnam has ever been delayed or canceled for lack of logistical support.
Army's AH-1G gunship, a proven record of close fire support. A helicopter with a capability that has grown over the years. Best known to the men it protects as the Cobra, or Snake. Here's TOW, acronym for Tube-Launched, Optically Tracked Wire Command Link Missile. It's another battle-proven weapon, a potent anti-tank missile which has been serving ground troops well since the early 70s. It was inevitable that they get together. This film introduces that combination. Cobra TOW is no hastily conceived marriage. Using a UH-1 airframe as a test vehicle, experimental tests of an airborne tow system took place in the mid-60s. In 1972, 2 UH-1Bs were equipped with prototype tow installations and dramatically proved the value of the concept in combat. It did what it was supposed to. It stopped armor. But a utility helicopter in a low-intensity hostile environment is a distant relative to what exists today. Here's the new Cobra TOW, AH-1Q or AH-1S. The fast, high survivability of the Cobra, combined with the tank-busting capabilities of TOW. It is a weapon system specifically designed to fight and survive in the mid-intensity combat environment found today throughout so much of the world. The Cobra TOW can be distinguished from the AH-1G by a few simple visual characteristics. Apparent immediately is the telescopic sight unit system mounted in the nose, the distinctive shape of the TOW missile launchers, and the linkages and rails of the helmet sight system. So the key elements of Cobra TOW are the stabilized telescopic sight with its optical relay tube, sight hand control and left hand grip, TOW control panel, and the pilot steering indicator, or PSI. The pilot and gunner station both are equipped with a helmet sight system. And the TOW missile launch tubes mounted on the outboard pylons with either 2 or 4 missiles per side. These outboard pylons are articulated launch constraints for firing and capture of the TOW missile. Stabilization control amplifier, missile command amplifier, and electronic power units for the TMS are located in the tail boom. Still retained in the Cobra TOW is the familiar M28A1 chin turret with minor modifications which has proven so successful on the AH-1G. It should be stressed that although the TOW missile has been in inventory with combat arms for years, the TOW missile system on the Cobra has just one element in common with its ground-based counterpart, the TOW missile itself. The fire control system and launchers, the test and maintenance equipment and procedures are totally different. Airborne TOW requires entirely different sighting and control electronics and different locations. So although the missile is common to both systems, from that point on, they're a different breed of cat. Here are the details of each of the subsystems which make Cobra TOW what it is. The telescopic sight unit, TSU, has a choice of either 2 or 13 power optics for target acquisition, TOW missile firing, and turret firing. After target acquisition, the launch sequence is initiated by lining the aircraft up with a target using the PSI. This assures that the missile launchers are within the missile launch constraints. The PSI is used by the pilot to establish and maintain pre-launch constraints. The gunner then receives a ready flag in the TSU, indicating he is cleared to fire. After launch, the pilot is able to initiate evasive maneuvers within the limits of the TSU gimbals. That's up to 110 degrees post-launch constraints to the left or right, 30 degrees elevation, and 60 degrees depression. Again, the pilot steering indicator provides a visual reference so that he doesn't exceed these limits. After the TOW has been fired, a sustaining flight motor is ignited, an IR lamp is illuminated, and the missile guidance system becomes operable. The TSU has an IR tracker which senses any difference between the missile position and its line of sight to the target.
through a pair of wires connected to the launchers which automatically uncoil missile spindles. Corrective guidance commands are automatically transmitted from the missile command amplifiers. Thus, all the gunner need do to achieve a hit is continue to hold the sight crosshairs on center of the target until impact. But Cobra TOW is a whole weapon system, far more than just the TOW missile. The inboard pylons can still carry 2.75-inch rocket pods and the M18A1 minigun pod, of which can be fired by either the pilot or the gunner. Also the turret system with its 7.62 millimeter. Thus the pilot, by means of his helmet sight system, can direct suppressive fire from the chin turret at targets other than the hard point targets being destroyed by TOW. And 40 millimeter grenade launcher is available for use even during the time when the TOW missile launch sequence is underway. Let's look a little more closely at the helmet sight system. The standard Army helmet has been modified with a visor-mounted sight. This connects by means of a magnetic contact and latch to mechanical flexible linkages attached to overhead guide rails which run the length of the cockpit. Thus, both the gunner and the pilot are connected to a common electronic sight system which can direct the chin turret to wherever either man looks. The primary role of the HSS is target acquisition, and often because of his higher seat position, the pilot is first to acquire a potential armored target. The gunner can slave the TSU to the pilot's helmet sight so that when the pilot acquires a target, the TSU will quickly slew to position, pointing at that target. The sight reticle on the gunner's helmet sight is automatically programmed to retract, so the gunner is instantly ready to look through the pre-aligned TSU. The introduction of any new system to the Army produces a need for training. In the case of Cobra TOW, operational training will be minimal. Not surprisingly, the training for adequate maintenance will be somewhat more extensive. Although the aircraft itself is virtually identical with a G, it is weapon systems qualification which will constitute the training emphasis. It might be mentioned that the training of air crews for the Cobra TOW will be on a total systems qualification basis. Both men will be pilots, qualified to fulfill either pilot or gunner functions. They will be an interchangeable team, an important factor since tactics will play a large part in the successful employment of this weapon system. Like the AH-1G, Cobra TOW is equally transportable to fill Army global commitments. There is a very slight gross weight increase of about 500 pounds, virtually no change in cubic feet of cargo space. So wherever the AH-1G can be shipped, there too Cobra TOW will be able to go. In 1972, a joint evaluation of a team of U.S., Canadian, and German personnel planned and conducted a series of exercises designed to determine the best tactical employment of a TOW-equipped Cobra. The location was Ansbach, Germany. Laser simulators were used from the G helicopters to simulate TOW firings. Comparable devices from the Leopard target tanks simulated threat air defense weapons such as the ZSU-23-4s, which would be found in a typical aggressor armor column. Smoke canisters were activated by these advanced laser fire simulation systems, providing an instant assessment of each encounter when either a tank or a helicopter was hit. The Cobras achieved exchange rates at an average of 17 to 1 and as high as 34 to 1. The tactical technique that proved the most effective was to ambush the armor from behind a tree line or defilade, pop up, fire, then remask. This simulation exercise proved that in the real world of the mid-intensity environment, the Cobra TOW would be an effective weapon system. In the spring of 1973, initial firings of TOW missiles were conducted at the Army's Yuma test facility. Special flight test instrumentation and high-speed cameras determined that there was no compromise to the structural integrity of the helicopter. Close examination of the aircraft after each shot revealed only very minor indications of the missile firings. Verification of the accuracy of the TOW system was next. Firings ranged from out-of-ground effect hover to forward speeds up to 170 knots, and at ranges from minimum to maximum for the TOW missile. During these initial tests, 23 successful missile firings occurred. Feasibility had been proven. Now was the time to hone the tactical capabilities of the system in the field with operational Army units. In 1974, at Fort Hood, Texas, an official Army follow-on evaluation was conducted. This test utilized 16 aviators considered typical of men found in a representative attack helicopter platoon. About a month of aircrew training was given in the Cobra TOW system with which none of the men were previously familiar. Then the missile launch sequences were begun. All of them used the same basic criteria: acquisition of a moving, variable speed, radio-controlled tank in rolling terrain covered with sparse vegetation. There were numerous wrecked, tracked vehicles which also helped provide cover and concealment for the moving M48 target tank. The targets were maneuvered to present only a quartering frontal presentation to the gunner. The helicopter launch envelope consisted of rising from behind cover to a hover altitude out of ground effect, acquiring the target, firing. Holding until impact, then remasking. Several side experiments were conducted, both with HEAT warheads and at extended ranges. In both cases, only 2 missiles each were launched. In both cases, both missiles were hit. Night firings also proved successful. This follow-on evaluation was one of the first conducted under operational conditions with an actual Army unit in the field. There were some pleasant surprises in this evaluation. Bore sighting proved to be less critical than was originally anticipated. One of the prototype Cobra TOW ships made 66 accurate launches without bore sight adjustment. An average time of only 3 minutes and 5 seconds was required for one man to reload 4 missiles. The sight reticle blur that is present in the TSU when the 7.62 minigun turret weapons are fired proved not to be too significant. Actually, 8 TOW missiles were launched during turret weapons firing, and all of them were successfully tracked throughout their flight to impact on the target. Changing tactics will undoubtedly require different employment of aircraft, and the Cobra TOW has been designed to live in the field with the troops. Here's a few examples. Preventative maintenance on the helmet sight system consists of wiping the rails with a clean, dry rag. No oiling, no specific periodic maintenance. It's been designed for very high maintainability. Another example. During run-up, a test tells both pilot and gunner if any one of the lights in their helmet sight is burned out. It's a replacement that can be made by the crew chief on the spot. Even should 1 or 2 filaments of the lamp fail during a mission, it's no problem. There are 3 separate filaments, any one of which can operate the sight reticle. So system backup, ease of maintenance, and reliability have been important Cobra TOW design criteria. As Army crews have become more familiar with this new weapon system, they have been quick to develop new tactics which exploit the advantages of the unique weapon mix. When teamed with an LOH, the important tactical element of surprise can be even more effectively exploited. Here's a good example of an experimental tactical technique. The range is 5,000 meters as the helicopter approaches a target area. A burst of 2.75-inch rocket fire creates the initial attack, putting the target in a defensive posture. Then the helicopter moves up to another closer firing position and, from a pop-up or hovering mode, uses the TOW system for a definitive kill. The same basic strategy becomes even more effective if 2 helicopters are used from different directions. A Cobra TOW or a G model with long-range standoff fires high-angle rocket salvos, distracting the target from the firing position. while Cobra TOW in another location is making maximum use of terrain masking and cover to deliver its lethal missile launches. The first production of the Cobra TOW helicopters has been delivered to the Army. The aircraft contains a series of structural and power modifications that will progressively increase its performance from that of the basic AH-1G. Yet it will retain the same basic handling characteristics. As the G proved its worth in a low-intensity combat environment, the Cobra TOW enters Army service ready to fight in any combat environment, including mid-intensity. Both the missile and aircraft are combat tested. So Cobra TOW actually enters Army service as a proven deterrent against any future aggressor armored forces.